Some of you loyal followers may recall that last year here on my YouTube channel, I was working on Arduino projects and electronics. And one of the things I was doing an Arduino weather station. And this is one of the remote sensor nodes that I had and built and programmed that would send temperature and humidity back, as well as barometric pressure. It has RF. This chip here is temperature and humidity, so it needs to have airflow over it. And I had this barometric pressure sensor that I mounted to this board and fashioned up a cable to plug it in. And I stuck it down on this plastic Tupperware container and hung it out on the wall on the porch. And it's been there working perfectly for 8 or 9 months. But what I want to do now that I have the 3D printer is I want to get into making a proper enclosure for it. And you have to think about things like leaving air holes so that there's airflow over the sensors and things like that. So here's a prototype, actually one of many iterations. And what I was going to do was have these 3 screws and hang it up on the wall with the box on the wall, and of course air vents here so that the airflow is good. And then I would mount the node onto this faceplate, and then basically that whole thing would go inside this box on the wall, which would allow me to remove it so that I could plug it in and reprogram it as needed. Now what I'm going to do is I'm going to use some nylon screws because they're not conductive on the board here. And also for the weather outside, there will be no corrosion. So what I'm going to try to do is use these tiny little, they're M2, they're 2mm screws, they're super tiny, and I'm going to use this 2mm tap, and I'm going to tap these 4 holes. Okay, now when I designed this, I made these holes go the whole way through so the tap would be able to thread the whole way through for longer screws, and then we'll use these tiny 2mm screws to hold the board down. Okay, so as far as tapping this, I have my 2mm tap, and I could just do this by hand, and I probably would have a little more control, but it does make your fingers tired. And I have this 4-piece pin vise set, which is really nice, and I'm going to see if I can fit this in here. If I can mount the tap in here, it'll be a lot nicer, and I think it'll still give me decent control for tapping this. So what I'm going to do is I'm going to start with it flat on the table and just go real slow till it takes hold. And I want to keep everything very square, and then just slowly let the tap do the work. Don't put too much pressure on it, you'll blow the threads right out. It's just ABS plastic. Back it up every once in a while, and you can see some of the shavings come out. Just clear them away, and then just continue. Go slow. I'm going to tap this one the whole way through, and there we can see it's coming out the hole on the bottom. So I'll just finish it, make sure that it's through the taper. And there we go. Back it out carefully. We should be good. Now with any luck, this tiny little 2mm screw will thread right in here. Don't want to put too much pressure on it. And it is threading in, but it has a little wiggle to it. And I'm starting to think that maybe this isn't going to be a long enough screw. So after playing around a little bit, what I found out was that the 2mm screws that I planned on using, I thought they were stripping out. I mean, they just weren't getting tight. They would have held, but they weren't getting tight where I was comfortable with them. And they weren't really stripping out width-wise. They just weren't long enough. Okay, so what I think I'll do is I'll use these M2 by 12s. They're just a lot longer, and they'll go the whole way through the plastic, and then I can cut them off afterwards. They'll also be a lot easier to deal with because I can hold on to them when I'm assembling it here. Yeah, so these are a lot nicer to deal with, a lot longer, and they thread the whole way through. Yeah, that's holding on there really solid. That's nice. That's what I want. And then I'll just take my end cuts here and just snip them off. They're just nylon screws. No biggie. Nice. Okay, so we have the board mounted to the lid here, as we talked about with the 3 screws. And what I'm going to want to do now is flip it over and install it into the box. So these 4 screw bosses here and the holes need to be tapped. And this is a 3mm tap, and I'm going to use these M3 screws. They're a little bigger. Now this is a sample that I did. I made a little screw boss here, and you do a lot of things like this, a lot of iterations, because you don't want to print that big piece. It takes 5 hours to print that box, but this little guy took like 16 minutes. So I decided, I have to decide what diameter I need so I can tap it and the screws will fit. And I put these little braces in here, like you see in a lot of plastic things, because otherwise they'll just snap off when you go to tap it or screw it in. So there's a couple of those little guys that I made. Okay, so I chucked up my 3mm tap, and I'm going to go ahead and tap down into these to prepare them. Now this is just a sample box. I have another one printing right now. So this is all a trial run. So I'll go ahead and tap these out, and then we'll see how this works out for us. Okay, so our concept here is this is going to go like this, and I'll probably hot glue this extension board down, wrap up the cable and plug it in here. Okay, put the battery in, and then this whole thing is going to flip over and snap into the box here. So let's try one of these 3mm screws and see how it goes. Okay, I mean, it'll hold, but I guess I should have learned from last time with the 2mm. They just don't seem long enough to be grabbing. I mean, they'll hold, they're not going anywhere, but I'd feel comfortable if they were a little longer. So maybe what I'll do is go with these. Yeah, I think I have enough room to put them in, and if not, maybe I can snip them off and they'll still thread in, so I'll give that a shot. Right, so I figured out that until this screw goes through here, there's just not enough length left that it's going to hold. And this is the only other thing I have. This is a really long one, but I think what I can do is just cut it off, and hopefully I won't damage the threads that much that they won't grab hold. And if not, I mean, it'll fit. I think it'll fit. I designed it. It's long enough there. I got lucky, but I wanted to mention when I designed this, I put these little ledges in here on this iteration, so that when this drops in here, it really is solid. The first one's kind of bent in the middle. So just some little things you learn along the way and adapt to them. It's pretty cool. So I think I'll use these wire cutters that are sort of round on the end. Maybe they won't damage the threads too much, and I'll just snip off a little bit of the length. And let's see if this will thread in here. I think it will. Just get it started. Yeah, that's going to work nice. That way I won't have all that length that I have to screw in, but it'll be plenty sturdy. Okay, let's see if we can glue this little guy onto here and get moving ahead with this. And this will plug into here after we're done. So let's try some hot glue on it. I think that's the best thing to do. It's a little messy, but that way if I need to take it off, I still can get at it. Little hot snot. Let's coil this wire up here and plug it in, get it out of the way. There we go. Get our battery here. I guess we can put that in. So let's take a look here. Can get some ventilation through the holes in the bottom. There are boards mounted. Hot glued that on there, wired up. Looks like a little bomb, doesn't it? Yeah, that fits in there pretty nice. That should work out pretty well. Now pretend that this is the wall. See, I could screw right into there, and that'll hang on there. And then this will come off so that I can reprogram it or change the battery or whatever, and that box just stays on the wall. Looking back at it here, maybe I should have done something different so that I could take the whole thing off the wall easily. Maybe just had it grab the screw in one of those holes in the back or something, but it'll work for what I want to do. It's pretty nice. I just want to show you the outcome of working on a project like this. You know, you end up doing a lot of pieces in between and a lot of iterations so that you can get the sizes right and the dimensions and the diameters of the screw holes and things like that so they can be tapped, and, you know, get the surface right and get your design. Look, this one's totally different. This one has the screw bosses slightly elevated up in the air with a lot more room underneath, and in the end I ended up just doing it this way. They grow up from the bottom of the case. So there's a lot of iterations and changes as you move on. And here's my project enclosure on the right, installed on the wall on the back porch with my other weather sensors. The screw fits perfectly where I wanted it. And then what we'll do is we'll take the sensor unit on the lid, pop it on here, put some screws in it, and give it a shot. I'm just going to put 2 screws in for now. And I'm interested in seeing if the vent holes on both sides and the bottom will provide me with accurate readings. And what I can do is compare those readings to the other sensors that are right near it. And just as a reminder, this is the indoor receiver that the outdoor sensor nodes send their information to. Temperature, barometric pressure, humidity, battery voltage, the last time it sent an update, and how many packets were sent and how many received. And P in the lower right corner is for porch. Every 30 seconds, it changes to one of the other nodes. Now on the bottom right, you see G for garage and the readings from that sensor node. It was my first Arduino project. I did it 9 months ago and coded it. It was very involved, and I haven't touched it since. They've been flawless. So it was a neat project. Well, I hope you've enjoyed this maker video. Maybe you learned something along the way, or were entertained a bit. And thanks for watching.